In this video, I'm going to go over the Unit 2A review, which covers all sorts of things with polynomials, the finding the roots, the solutions, switching between standard and vertex form, analyzing it, sketching it, multiplicity. And there's going to be a calculator and a non-calculator part. So the first things that we're doing here are not using a graphing calculator. So for number one, it says, given this polynomial f of x and g of x, find the quotient and remainder when f of x is divided by g of x. So we're going to do polynomial long division here, and we are dividing by x minus 2 because that's our g of x factor. So this is our g of x function. So we're going to divide this into our polynomial. So we're going to divide in x minus 2 into the cubic function, that 2x cubed plus 8x squared, etc. And so this first term here goes inside of your box. And now you can kind of fill up your missing information. So x times this space up top will multiply together to give us 2x cubed. So x times 2x squared will give us 2x cubed. Then we can multiply the top and the bottom together to get this bottom box. So 2x squared times negative 2x gives us negative 4x squared. And now the number in this box and this box needs to add to our x squared term. And so negative 4x squareds plus 12x squareds will get us up to that 8x squared. Then you can figure out what this top box needs to be. So x times 12x would give us 12x squared. Then we would multiply top and bottom to get negative 24x here. And then this box and this box needs to add to our x term of negative 5. And so negative 24x plus 19x will get us to that negative 5. So then we can figure out that this top would need to be 19 because x times 19 would give us 19x. Then we can multiply top and bottom to get negative 38. And then we know that that number and this number have to add up to the final number here. And so negative 38 plus plus positive 33 would get us to that 5. And so then this would be our remainder. So the 33 would be our remainder. So then you can write the function as q, which is the q of x is your quotient. So that's your answer, or the part on the top. Okay, so what it divided down to now. And then plus your remainder, which is what's in this box, and that's 33, over our divisor, which is what we're dividing by. So that's this piece right here. So x minus 2. Then it says, is g of x a factor of f of x, and how do you know? And so the answer to that would be no, because there's a remainder. Or because the remainder doesn't equal 0. So if it evenly divides in there, there wouldn't be any remainder left. Number 2 says, given f of x equals this function, use limits to describe the end behavior. And so remember, we're not doing this with a graphing calculator, so you need to know about the degree being odd means one branch is up and one branch is down. And then the a value is positive. Okay, so our a sub n term is greater than 0 and our degree is odd. So we know that that's going to be a branch down on the left and up on the right. So that means that our limit as x approaches negative infinity. So when your x's are at negative infinity, this branch is down at negative infinity as well. And then when our x approaches positive infinity, so on the right side, our graph is up at positive infinity. Number 3, given this function, state the axis of symmetry and the vertex. So this one is written in vertex form. So remember that vertex form is a times x minus h squared plus k. Remembering that this h value here is the x coordinate of your vertex. And then the k value here is the y value of your vertex. So in this case, we have a positive 2, which means that we actually plugged in a negative 2 into that. And so that's our x coordinate of our vertex. And then the y coordinate of the vertex is negative 3. And remember that your vertex is on the axis of symmetry. Okay, so we have something that looks like this. That's a terrible graph, but you get what I'm saying. So this is our vertex, negative 2, negative 3. And the axis of symmetry is the fold line. So it's the line that goes right through here, which is equal to that x coordinate. So in this case, x equals negative 2, but the axis of symmetry is always equal to your x coordinate of your vertex. Then when we want to write this in standard form, we're going to want to multiply out this binomial here. So we've got the x plus 2 squared. And if you want to do this in the box, you can. But so you're doing x plus 2 times x plus 2, or if you FOIL or however you multiply that. But we get x times x is x squared. 2 times x is 2x. 2 times x is 2x, and then 2 times 2 is 4. So this gives us back x squared plus 4x plus 4. And so remember that that's for this part. So we still have 2 times that x squared plus 4x plus 4. And we have the minus 3. So then we'll distribute the 2 into all 3 of these pieces. So we have 2x squared plus 8x plus 8. And then we have the minus 3. And then these are like terms. So we would get 2x squared plus 8x plus 5 as our standard form. So f of x equals that. So here's your standard form, vertex, and axis of symmetry. Then number 4 is given to us in standard form, and it wants to know the axis of symmetry and the vertex, and then have us write it in vertex form. So you have a couple different ways to do this. So you can start with just finding the vertex and the axis of symmetry. So the axis of symmetry, when it's in standard form, the formula is x equals the opposite of b over 2a. So then you can go into here and you can say, all right, well, our b term is 8, right? So b equals 8. And then our a term is negative 1. So remember that the a is always in front of the x squared, the b is in front of the x, and then c, which we're not using in this case, is the constant. So then in this case, we have that the opposite of b, so the opposite of 8 is negative 8. And then on the bottom, we have 2 times the a value, which is negative 1. So then we end up with negative 8 divided by negative 2, which gives us 4 for the axis of symmetry. So the axis of symmetry is 4, and that's also the x coordinate of our vertex. So then we take the 4 and we plug it into the function. So you do f of 4 So you do negative times 4 squared plus 8 times 4 minus 3. So just plug it into the function. So then 4 squared is 16, and you have that negative. 8 times 4 is 32, and then we have the minus 3. Negative 16 plus 32 is 16. Minus 3 is 13. So that means that when we have an x value of 4, our y value is 13. So our vertex here is 4, 13. So then you can write this in vertex form, because remember that vertex form is a times x minus h squared plus k. And our h value here is 4. So we'll just plug in a 4 for this h. So this is going to say x minus 4. Our y value of the vertex is 13, and that's our k value. So our k value is 13. And then the a value just matches the original a value. Okay, so our original a value here was -1. So that's what our a value still is. So this is -1 out here. So that's one way to find vertex form, to actually use this formula to find the axis of symmetry and then plug it in. The other way you can do this is by completing the square. So if you don't like the way I just did it, you can do it this way. Also, if you don't like completing the square, you don't have to do it this way. Okay, so this is just another way. So if we have negative x squared plus 8x minus 3. So now if I'm going to complete the square with this, the first thing I actually have to do is take out this -1. So you have to factor out the a value. So negative x squared divided by -1 is x squared. 8x divided by -1 is -8x. And then I'm going to leave the minus 3 on its own. So then I'm going to complete the square, which is taking this middle number, dividing it by 2, and then squaring it. So -8 divided by 2 is -4. Squared is positive 16. Now you have to cancel this out, okay, because you just added it in here. And so that means we changed the expression. And really what we added was a -1 times 16. So we actually added -16 to the equation. So we're going to have to cancel that out by adding 16 so that those zero each other out. Then you're going to factor it. Okay, so now this inner part right here, let me highlight it. So this inner part right here factors to x minus 4 squared, because that would give us -4x and -4x for the middle term, and -4 times -4 for the end term. And then these combine to 13. And so then you can see that this is the same, this is the same thing that I got doing it the other way as well. Okay, so that negative times x minus 4 squared plus 13. So two different ways, same outcome, whichever you prefer. Number 5, how many roots does this function have? So remember that the roots equals the degree. And the degree here is 3. So f is going to have 3 roots. Now when it says list the possible rational roots, remember this is taking the p's divided by the q's. And remember that the p is the final number, or the constant. Okay, so the factors of p are the factors of 24. So 1, 2, 3, 4, 6, 8, 12, and 24. And then q in this case is 1. Okay, so you're just going to divide by 1 each time, which is nice because then these are just your answers. So your possible rational roots are plus or minus and then all of the p's divided by q, which is just 1. So just plus or minus all of these. 1, 2, 3, 4, 6, 8, 12, and 24. And then select which of the following is a 0. So now you're just deciding which of these is actually a 0. And if it's a 0, that means it has a remainder of 0. And we can tell this by plugging them in. Okay, so when you plug in the zeros into the function, if they equal out to 0, that's the remainder. Okay, and that's what we're looking for. So we're just going to plug these in and it'll give us back the remainder. And so we'll plug it into x cubed plus 5 times x squared minus 2 times x minus 24. And so we're just going to plug each of these zeros in. So the first one is 3. So I'm just going to plug this in for x into the function. And then just simplify. So 3 cubed is 27 plus 5 times 3 squared is 9. Negative 2 times 3 is negative 6. And we still have that negative 24. So we have 27 plus 45 minus 6 minus 24. And so 27 plus 45 is what? 60, 72. And then negative 6 and negative 24 is negative 30. And 72 minus 30 is 42. So this is the remainder when we plug in 3. So when we plug in 3, we get a remainder of 42. So that means that this is not a 0. Then the next one, we'll do the same thing. So we're going to plug in negative 3 now. Okay, so I'm just going to erase this and plug it in here. So now we're going to plug in negative 3. So negative 3 cubed is negative 27. And then we have plus 5 times negative 3 squared is positive 9. Negative 2 times negative 3 is positive 6. And then we have that minus 24. So we have negative 27 plus 45 plus 6 minus 24. So then positive 45 minus 27 are in a negative 27. So negative 27 and positive 45 is 18. And then 6 minus 24 is negative 18. And 18 minus 18 is 0. So f of negative 3 gives us a remainder of 0. So that means that this one is a factor. And then we can plug in 1, but it appears that this question is saying that there's only one of these is going to be an actual 0. So we've probably found it. But we can plug it in anyways, just to make sure. So now plug in 1. And so we'll go ahead and plug in 1. So 1 cubed is 1. 1 squared is 1 times 5 is 5. Negative 2 and negative 24, which is not going to be 0. So that's not going to equal 0. So this is not going to be a factor. All right, so then it says, using the 0 you found above, determine the remaining zeros of f of x. So now what we need to do is we need to divide this factor into the polynomial. So if x equals negative 3 is a 0, then it means x plus 3 is a factor. So then we'll put x plus 3 and long divide it into this polynomial so that we can get it down to a quadratic. So the x cubed goes in here, Okay, so we're putting this polynomial in, right? And then x times x squared gives us the x cubed. So now we can take top times the bottom to get 3x squared. And then this number plus this number has to give us our x squared in our polynomial. So 3x squared plus 2x squared. And then x times this gives us 2x squared. So x times 2x gives us the 2x squared. So now we can do top times bottom, which gives us 6x. And then 6x plus this needs to give us negative 2x. So 6 minus 8 gives us the negative 2. So then x times negative 8 gives us the negative 8x. Negative 8 times 3 is negative 24. And then this number plus this needs to equal this last number. And negative 24 plus 0 gives us that. And this is our remainder. So that's good. So now we have our polynomial down to x plus 3 times x squared plus 2x minus 8. So now you want to factor this. And the a value, or the first number, is 1. So we just need to find the factors of negative 8 that add to 2. And so that's 4 and negative 2. So positive 4 times negative 2 gives us that negative 8. And our middle terms would be 4x and negative 2x, which would give us 2x. So then this is our polynomial factored, and we're looking for the remaining zeros. So we set it equal to 0 and we solve. So x plus 3 equals 0, x plus 4 equals 0, x minus 2 equals 0. So we would subtract 3 from both sides, we would subtract 4 from both sides, and we would add 2. So our 3 zeros are negative 3, negative 4, and 2. Number 6, given the polynomial function, how many zeros does it have? List the possible zeros. And then given x equals 1 is a solution, find the remaining. So again, the number of zeros it has is equal to the degree. So this is 3. And then listing the possible rational roots are your p's over your q's. So your p in this case is 1. And your q is also 1. So that's only 1 divided by 1. So your possible rational zeros are just plus or minus 1. And now I'm telling you that x equals 1 is a solution, so find the others. So again, if x equals 1 is a solution, then x minus 1 is a factor. So you're going to divide that into the polynomial to get it down to a quadratic. And so now we're using this polynomial. So this x cubed goes inside. And x times x squared gives us x cubed. X squared times negative 1 gives us the negative x squared. Then this box plus this box has to equal our x squared term. And it's already, so negative x squared is already negative x squared. So we have 0 x squareds to add to it. And so how do we multiply to get 0? By multiplying by 0. So that's a 0x. 0 times negative 1 is 0. So this is 0x is here. And then this box plus this box needs to give us our x term of 1x. So 0x plus 1x gives us 1x. X times 1 gives us the 1x when we multiply top times top. And then we multiply tops times bottom, we get the negative 1. And then this box plus this box needs to equal negative 1. So negative 1 plus 0, which again is good because this is our remainder. So now we have x minus 1 times x squared, and I'm not going to write this 0x. I'm just going to do x squared plus 1. And we want to find the zeros, so this is equal to 0. So we would say, and now this doesn't factor. So x squared plus 1 doesn't factor. If you have a difference of squares, so if it was like x squared minus 4, this would factor to x plus 2, x minus 2. Or if it was x squared minus 25, then it would factor to x plus 5, x minus 5. But if it's a sum of squares with an addition there, then it doesn't factor. Okay? So this one isn't going to factor. So we'll just set them equal to 0. So x minus 1 equals 0. And I'll be able to isolate the x term on this one as well. So I'll just set it equal to 0. So here I'll add 1 to both sides. Here I can subtract 1 from both sides. And then I'm able to square root the answer here. And remember, when I square root, I need to put a plus or a minus. So x equals plus or minus square root of -1. And remember that the square root of -1 is I. So plus or minus I. So those are your three solutions. 1, I, and -I. Number 7, a polynomial g of x has these given zeros. What's the least degree it could be? So this is where you need to look for the partner or the conjugate solutions. So 4, just 4. But 4i has a radical in it because I is the square root of -1. So this one has a partner. So remember, if 4i is a 0, so is -4i. And then square root of 3 is a square root. So it has a partner as well. So its conjugate is a root as well. So this gives us 5 for the least degree. Okay, because there's 5 roots right there. So state the roots. So 4, 4i, -4i, square root 3, and negative square root 3. Then for the x-intercepts, remember the x-intercepts need to be real numbers. So out of the roots, which ones are real numbers? Well, 4 is a real number. Square root of 3 is a real number. And negative square root of 3 is a real number. So those are all of your x-intercepts. Imaginary numbers are not x-intercepts. Then let's write this in factored form. So remember that your factors are always going to be x minus the root. Okay, and we're going to have 5 of these because we have 5 roots. So we have x minus 4 as one of the factors. Then for 4i, it's x minus 4i. Then for -4i, it's x minus -4i, so it turns to plus 4i. Then for square root 3, it's just x minus square root 3. And for negative square root 3, it's x minus negative square root 3, so it turns to x plus square root 3. So then those are your 5 factors. So that's g of x in factored form, and you should write g of x in front of it. So let me just move this one over so I can write it. So we should have g of x equals that. Number 8 is basically the same thing. So here's a couple zeros. What's the least degree? So remember that square root 2 comes with a partner of negative square root 2, its conjugate. So then we can see that there are 3 solutions there. So the least degree is 3. Those roots would be negative square root 2, square root 2, and then 3. The x-intercepts, all of those would be x-intercepts because they're all real. So square root 2, negative square root 2. Oops, I guess the purple one was negative square root 2. So negative square root 2, square root 2, and then 3. All of those are real, so all of them are x-intercepts. And then we'll write it in factored form. So we would have x minus negative square root 2, so it would turn to x plus square root 2. We would have x minus square root 2, and then we would have x minus 3. Now this one wants us to expand it and write it in standard form. This means we're going to have to multiply it. So anytime you have conjugates, I would multiply those together first because you're going to have numbers cancel out. So I would start by multiplying these ones. So we have x plus square root 2 and x minus square root 2. So x times x is x squared. X times square root 2 is just square root 2x. And then negative square root 2x. And then negative square root 2 times square root 2 is negative square root of 4. And the square root of 4 is just 2. So this is negative 2. So then we see that negative square root 2x and positive square root 2x cancel. So we just end up with x squared minus 2 for this first part. And then we still need to multiply by x minus 3. So then we can multiply this in the box again, or you can FOIL it, whatever you want. And so we have x squared minus 2 times x minus 3. So we get x cubed minus 2x, negative 3x squared, and positive 6. So if we just take those out, there's no like terms. So we'll write it in standard form, x cubed minus 3x squared minus 2x, and then plus 6. And then I'm going to leave some space so I can write it as g of x equals that. Number 9 is just like that one. And so in this case, we have 3i, which is imaginary. So that has a partner root. It has a conjugate. So then we'll state these roots, which are negative 3i, 3i, and then negative 2. And so then that is 3 roots that this could have. And then the x-intercepts, remember, are only the real numbers. Okay, so then negative 2 is our only x-intercept. When we write this in standard form, okay, it's going to be x minus a negative 3i, so it'll turn to x plus 3i. Then x minus 3i. And then x minus the negative 2, so it turns to x plus 2. And so that's the factored form of g of x. Then we want to write it in standard form. So again, this means multiplying it out. So start by multiplying those conjugates. So multiplying the conjugate factors, which is x plus 3i and x minus 3i. So we get x squared. We get 3ix, negative 3ix. And then negative 3i times 3i is negative 9i squared. So these ones are opposite, so they will cancel. And then negative 9i squared. So you have negative 9, and then remember I squared is negative 1. So negative 9 times negative 1 is positive 9. So these multiply to be x squared plus 9. So that's for this part. Then we need to multiply it by x plus 2. So we have x squared plus 9 times x plus 2. So we get x cubed, 9x, 2x squared, and 18, none of which are like terms. So I'll take them out and write them in standard form. So x cubed plus 2x squared plus 9x plus 18. Number 10 wants us to sketch the graph of this function. So we should state the zero. We should also state the zeros and their multiplicity and then describe the end behavior. So the zeros, remember, come from these factors, okay? So the zero, if the factor is x minus 1, the 0 is 1. And then this one is there twice. So this one has a multiplicity of 2. This next factor says plus 3, which means that we really plugged in a -3. So the 0 is -3 and it's only there once. So you don't have to write multiplicity 1. I'm going to just so that we know. And then the x plus 1 factor means that the 0 is -1. And then again, that's only there once. So the multiplicity is 1. So remember, when you have an even multiplicity, this is just going to touch the axis, okay, or touch it there but not go through, where the odd multiplicities are going to cross. Okay, so it's going to touch, or maybe you call it bounce. So let's plot these zeros. So we have a 0 at 1. Okay, so here's 1. So I know it's going to cross there. I have -1. And then I also have -3. So there's the 3 zeros. Then if we think about the leading term, so we've got an x, an x, and an x. And really this is an x squared because it's there twice. So our leading term, or our leading coefficient, I'm just going to put leading term here. So our leading term is going to be x to the 4th, because we just have 1x, 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 and 1x. Okay, so it's really x squared, x, and x. That's going to be x to the 4th. So this one is even, so both ends are going the same way, and a positive leading coefficient. So we know it's going to be up on both sides. Okay, now it's going to do different stuff in the middle here. Okay, but we know on both sides it's going to be at positive infinity. Okay, so I know my branch is going to be up at positive infinity on both sides. And then I also know it's going to have to hit at these zeros. Now it's going to bounce at 3. So when it comes down here, it's going to bounce at 3 and go back up. Okay, then it's going to have to cross at -1, and it's going to have to come back up and cross at +1 so that it can go back up to infinity. Okay, so bounce at -3. Oh, sorry, that's wrong. I was reading them in order. Hang on. Okay, this is wrong. So it should, I was reading them in order right here. Okay, so at -3, it should cross. Okay, so at -3, it should cross and go through. Then it's got to come back up to go through -1. And then it needs to come back down so that it can bounce at 1 to go back up. There we go. Okay, so cross at -3, cross at -1, and then bounce at 1. And then both ends need to be going to positive infinity. And then what's the maximum number of turning points? And remember, you do the degree minus 1. So the degree here is 4, minus 1 equals 3 for the turning points. Number 11, basically the same thing. So this first factor of x is a 0 of 0. Okay, so we've got a 0. And then we have -2. And then we have 1. Those are our zeros. Okay, now the multiplicity of 0, it's only there once because we just have this here once. So this is just a multiplicity 1. -2 is there 3 times. So this is a multiplicity 3. And then 1 is there twice. So this is a multiplicity 2. So it's going to bounce at 1 and it's going to cross at these two that are odd. So we've got 1 at 0. Okay, we're also at -2. And then we're also at 1. And maybe I'll spread those out since we'll just make this a little bit wider. So we'll go at 1, -1, -2. So we have a 0 at -2, at 0, and at 1. And now this one is an x times an x cubed, because this will be there 3 times. So for our lead term, we have an x cubed times an x squared. So this gives us x to the 6th, which means both ends, since this is 1x to the 6th or a positive, means both ends are going up. So I know that we're going to end up on both sides. So now at -2, remember I need to cross because it's an odd multiplicity. So we're going to have to go through -2. And then we're going to have to cross at 0 since 0 has an odd multiplicity. So we're going to have to cross at 0, come back down so we can bounce at 1. Okay, so cross at 0 because it's an odd multiplicity. Cross at -2 because it's an odd multiplicity. And then bounce at 1. And if you want to be more accurate, which I don't care, but if you want to be more accurate, since this is a -3, or since this is a 3 multiplicity, it's really going to like come through and level out. Okay, so it's going to do one of these going through. Okay, so if you want to make it look a little bit more accurate, you could. I don't personally care, but you might. And then what's the maximum number of turning points? So 6 minus 1. Whoops. So 6 minus 1, which is 5 maximum turning points. Number 12, sketch a graph with the given characteristics. So our leading coefficient in this case is positive, and then we've got these zeros. So this is going to tell us that our degree, okay, because we have this one here 3 times, this one's here once, and then this one's here twice, right? So we have 3, 4, 5, 6 for the degree. Then we want to sketch this out. So x equals, and now this one's giving us the zeros, so we don't have to do opposite. So this one's giving us the 0 at 2, at 5, and then at -4. And our degree is 6, so both ends are going to be going up again, right? It's going to be doing different stuff in between, but both ends are going to be going up. Okay, at -4, which is this one, it's got an even multiplicity, so it's going to bounce. Okay, so we're going to start up, we're going to come down and bounce at -4. Okay, then the next one we have to get to is 2. And so at 2, that's an odd multiplicity, so it's going to cross at 2. Okay, so when we come back down, we have to cross at 2. Okay, so it has to cross through at 2. And then it's going to need to go to 5. And 5, remember, is a multiplicity of 1, so that's odd. So it's going to cross at 5. So I'm just going to go back up and cross at 5, and then just keep going up so that both ends go up. Number 13, the leading coefficient is negative, and we have these different zeros. And so if we add these up, okay, this is 1, this is here twice, and this is here twice. So that's a degree of 5. So we'll have one branch up and one branch down. Now this is negative, so it's going to be starting high and ending low. So our branch is going to be up here, and it's going to be down on this side. Then we need to cross at -3, 0, and 6. Okay, so those are the places that we're going to need to cross. So at -3, it's there once. Okay, so then this is going to cross because it's odd, multiplicity. So we're just going to need to start up and then cross through the -3. Then when we get to the 0, it's going to bounce at 0 since it's there twice. So it's going to cross at -3. It's going to go up and bounce at 0. And then it also needs to bounce at 6. So it's going to go down, come back up, bounce, and go back down. And you can make it look nicer than mine if you want to. But so it's going to start high, go through -3, come back up to bounce at 0, go back down, and then bounce at 6 and go back down.